Okay, Sam, go ahead and read example number 1.
Solve the differential equation dy dx equals 3 over 2 minus x.
So I'm just going to do two things at the same time. We're going to multiply by dx and integrate. So y is equal to the integration of 3 over 2 minus x, and someone's still talking over me. We're on the next page. Okay, who is my u for this one?
2 minus x.
2 minus x. So we have u is equal to 2 minus x. du is negative dx. And when I compare, what do I not have here? Basically a negative, right? So let's go ahead and get rid of the negative to the other side. And let's also bring the 3 to the front. So we get y is equal to, oh, perfect. Negative 3, because we're taking out a negative and a 3. Integral of 1 over u du. And then we know integration of 1 over u was what? Natural log of the absolute value of u plus c. And let's plug it back in. And we're done with that one. So this portion, front and back, is basically like old information, okay? But with some applications. Everyone good with that? All right. Let's go to number 2. Alan, read number 2, please.
Find f prime of x given f of x equals the integral of x, 3x, 1 over 3.
So this one is our second fundamental theorem of calculus, which states to find the derivative, all you have to do is plug in the upper bound into my domain. And then after that, find the derivative of that upper bound, which is how many? 3. Minus, and then plug in the lower bound into that domain. So we have 1 over x. And what's the derivative of the x? 1, and that's it. Of course, you don't have to write the 1. All right. Moving on to example number 3. When you are finding the area of a certain region, area is denoted by the integration. So in this case, I'm going to show you by hand, and then afterward, let's see if there's a calculator trick behind it. So we are going to integrate the indicated region. What's my lower number here? What is this, and what is this? 0 and 4. I think 4 was already there. And let's put in the function given, 2x over x squared plus 1 dx. So who's my u? Very good. X squared plus 1, which gives me du is 2x dx. Do I already have that as it is? Yeah. So I have the integral. Now, since I want to change the bound, I'm not writing 0 and 4. So when I plug in x equals 4 and x equals 0, what is my u for x equals 4? 17. What about x equals 0? 1. So we have 1 to 17, so I don't have to convert it back in terms of x. So we have 1 over u du, which gives me the natural log of the absolute value of u. And we're looking at our bound from 1 to 17. So do I need the u in absolute value form anymore? Because 1 is a positive number, 17 is a positive number already. So when I plug it in, we get the following. Natural log of 17 minus a natural log of 1. And what is natural log of 1?
0.
So all that is 0. So that means this is our final answer. But let's kind of do a little guess and check real quick, or more like estimating. Go ahead and make your vertical line through the shaded region. And I want you and your partner to decide on what's the best possible answer it could be just using your eyes. how many whole areas can you count and maybe some partial? Just approximate it. Hey, Ruby, what was it? 2 point what? 7.5. Very specific, right?
I'm thinking 2.62.
I'm thinking like 3.
2.6, 2.5?
Yeah.
More like this?
2.95.
2.95. Let's try 2.95, all right? So then, let's go ahead and type this in on the calculator. So grab one from the back if you need, because the back is all calc.
My gosh.
So our natural log of 17. I mean, someone's pretty close.
It's me.
Should we give credit to the numbers? Right, Xavier on that one. Was that?
Do I get an extra point on the next quiz if I'm right?
Oh, no, that's not how it works.
Yeah, there it is.
All right, 2.833.
Oh, I think we were like
So that would be the exact value, and that would be the approximated value. There's actually a trick on the calculator that I'm going to share with you guys. So let's go ahead and box off a little bit on the side. Make sure you're writing this out. Because if this happens to be on the calculator portion, and you do all that work for no reason, that's going to be sad, right? So if this were to have been a calculator portion, you'll put in 0 to 4. And let's write in the actual equation given to us. I hope you're writing. So at this point, I did no math. All I did was I copied what was given to me. So when I go to math number 9, math 9, 0 to 4, put in the value. Ooh, 2x, x squared plus 1, and then we have dx. So I'm anticipating to get 2.833. Someone press enter. Yep. So if I ask you by hand, we did it. If I ask you on the calculator, it'll be very easy on or using math 9. Okay? So don't miss it if it is on the calculator portion on your next assessment. All right, last page. On the last page, we're going to use almost all of them on the calculator. So let's write all the tricks behind this. Jameson, let's read example number 4.
average value. The demand equation for a product is P of X equals 90,000 over 400 plus 3X. Find the average price P on the interval 40 is less than or equal to X is less than or equal to 50.
All right, for the average value, we have the lower and the upper. So we know at the very end, we have to divide it by what number?
C.
How many? 10?
10.
So I'm just going to write out 1 over 50 minus 40, just for teaching purpose. And then we're looking for 40 to 50 of the function given. So again, I'm just copying what is presented to me and not basically doing any math. And our integration symbol is where again? Math number 9. Let's type that in. The only pieces, before you put in math 9, put in the fraction 1 over 10 at the beginning. I know. So 1 over 10, and then do your math 9. Oh, not on the bottom.
Wait, hold on.
I messed up too. It's okay.
Yes, I got it.
No! I got it. 168 points. Shut up, Ruby.
That was fast. Ruby, we're going to give everybody a chance to type it in. But I think your answer was correct, though.
Oh, I got 16.
Y'all can't type.
I got negative 1,000.
Oh, goodness. You're rushing.
Is that not right?
Do you have what I have?
Yes.
Okay, Ruby, I think I agree with yours.
90,000.
168 point, and money goes to the penny, so 27.
Oh, I see what I did.
All right. You ready for the next portion? And this one, we're gonna need our PVA pretty soon. All right,
I mean, it's the same, just a
Sam, go ahead and read number 5 in part A, please.
Me?
Mm-hmm.
Oh. Which one?
The next one.
In which direction is the particle moving at time t equals 1.5? Just
Did you read the original too?
Oh, you said read 5A.
Okay.
Do you want me to read?
That's good.
I can't.
That was perfect.
It might be like.
We're looking for when time is equal to 1.5. All right. Since again, this is a calculated portion, plug in the 1.5 into that t value on your home screen. So I have 1.5 squared. Should we do a race? Go. Go. You're plugging in 1.5 into the function given.
Someone else. 1.5. Oh wait.
1.5 is the answer.
2.25. Got it.
I hope you have a negative answer.
Yeah, that's a negative answer. I got
1 million.
I got a negative answer.
All right. So I have negative 1.167. So let's see what our PVA says. If you already have this memorized, great. But I'm going to leave this up for those of you guys that needs it. All right. When our velocity is negative and our particle is moving along the x-axis, where is it going? Oh, it's moving along the x-axis. It's negative. It's going to the left. And that is because V of 1.5 is negative. Make sure you're writing this down. All right, and then it says to find the acceleration. So going back up here. Given the velocity, acceleration is a derivative of the velocity. So I am going to rewrite this one as V prime. And prime is our derivative. What number or what math number do we go to for deriving? Math number 8. So let's go to math 8. And then it's always with dx. Type in the function. And then it wants it at 1.5. So there I have it. Let's write that on your paper too so that we know what it looks like. Oh, I put the integral by accident. It was parentheses. So how many do we get on V prime of 1.5? 2.778?
Well, it's like 6. Oh, cool.
All right, part C. Sophia, let's read part C.
Is the particle speed increasing or decreasing at t equals 1.5?
So for us to know if it's increasing or decreasing, it is increasing when the velocity and the acceleration has same sign. It is decreasing when the velocity and the acceleration has opposite sign. So in this case, our velocity was negative. What was our acceleration? Positive, because we just found it on part B. So let's write speed as decreasing. Decreasing because V of 1.5 and A of 1.5, they have what kind of sign? Opposite sign. All right, Gianta, let's read part D.
Given that x of t is the position of the particle at time t and that x of 1 equals 5, find x of 2.
All right, so we need to go ahead and find the position. So in this case, we found velocity, we know velocity. To find the position, we have to go ahead and integrate. Okay, so this part is going to involve some work. So let's go ahead and rewrite this as the following. This right here. I'm going to use the room over on this side. We have V of t is equal to, oh, can y'all even see? Kind of. There we go. Let's go ahead and separate these. If I have t squared over t, how would I simplify that? T. And then on the next one, I'm just going to write out minus 4. And then 1 over t. Then that way, when I integrate 1 over t, it's going to be the natural log of that t value. So let's go ahead and find the position of this one by integrating on both sides. So it's going to give me p of t is going to be, let's write the understood 1. So doing a recap on anti-deriving is 1 over the new power, which is always 1 more, t squared, and leave the minus 4. And when I integrate 1 over t, what was it that we did the whole time today?
11.
Natural log of t. And then we need plus what at the very end?
C.
C. And yes, it should be absolute values, but then since my values right here given are already positive, I'm going to go ahead and ignore that part. Okay? What's up?
So how did you get the t prime minus 4 times 1 over t? Like where
Right here?
yeah.
4 over t is technically 4 times 1 over t. Just rewriting it. So if you have negative 4 over t, that's the same thing as pulling out the negative 4 times 1 over t. Okay?
What happened to the t squared?
Where's the t squared? Oh, t squared over t is just t. We're simplifying. Here we go. T squared over t. T's cancel out, so I get 1t.
Oh.
Okay? All right. So let's move on. On part D says the following. We know the particle is 5, so let's write out 5 is equal to, and we're plugging in 1 into our t value. So I have 1/2 times the 1 all squared minus 4 of the natural log of 1 plus c. But what do I know about the natural log of 1? 0. So really in the end I have 5 is equal to, that's going to give me 0.5. And then we have plus c. So how many is my c value then? 4.5. So I could write out x of 2, which in this case is p of 2, is equal to, we have 1 over 2 times 2 all squared minus 4 natural log of 2. And since I found the c, plug in 4.5. Let's go ahead and type all that into our calculator and see what decimal value we get.
Where's Owen on the calculator?
It's to the left of the 4. Look at 4 to your left.
Yeah, where's the log? Oh.
Okay, how many?
3.727.
3.727. Done. Okay, now let's go ahead and compare E and F, because it sounds the same. So read E and F to your partner, and y'all decide on what is one trying to tell us versus the other.
Okay. Find the total displacement of the particle from t equals 1 to t equals 2. How far is the particle from where it started? And find the total distance traveled for the particle from t equals 1 to t equals 2. How far is the particle actually traveling? How far is it from here to here?
Hmm.
How far is it?
So we're trying to find the total area under the curve. So in this case, I want you to write this out. It says from t1 to 2, so we know our lower bound is 1, upper bound is 2, right? Of the function given. And someone type this in for me and tell me what you get. Go, go.
Oh, wait, just did the wrong one. Oh.
Negative
1.273. Now, if you want to draw the next piece with me, go for it, but you don't have to. And I'm going to explain why that's a negative number. So if you were to graph this, it's going to hit 2, 0, and the graph is going to look almost something like this, but not exactly. And if I were to go ahead and create the area pertaining to the axis and also that point, where's my graph? Is it above the x-axis or below? That's why it's negative, okay? Now, I'm never gonna ask you to make this and describe that to me, but that's the bottom line of it. So then, the total distance actually traveled is always positive. This is always positive. So that means, if I were to find the integral from 1 to 2 of this function, we would have to put that into our absolute value instead. And that would simply give us what compared to the one right above? 1.273.